All right, thank you, Ryan. Hello, everyone. I am presenting just at an LLM. I'm Alicia Powers. I'm a data scientist at Core Harmonic. I strive to make data understandable and make data exploration easy, which is one of the reasons why I use Neo4j. Right now I'm focusing on how to make high quality recommendations, specifically around food. So this is me actually 8 years ago. This presentation is kind of a sequel to a presentation I gave called "Who Cares What Beyonce Ate for Lunch." It was about how to use structured data, put it in a graph, and get insights. So I'm going to talk a little bit about what I did in that presentation because it's a precursor to what I did with the LLM. So I'm starting with structured data. The Center for Disease Control does a survey of the health and nutrition of American citizens. It takes 2 days of food intake data, and so you have nutrition with all the data that you get, plus some personal level characteristics. So from that data, I derived this schema. So if you look kind of to the left, there's a person node. The circle is a person node, and right to the left of that is a rectangle with all the characteristics I have. What I want to point out that's most important right now is I have information on someone's weight and their height, so I can calculate a BMI or a body mass index and that's what I use to figure out if someone is overweight or obese to figure out who may need some help. Um, that person node is actually connected to an event node. I call it an event. I call it an eating event because it takes place at a certain time or a certain place. And on that relationship, there's a key on whether the eating event happened at your house or someplace else. And the eating event tells you the time that the eating took place. So right now we're looking at a young man who's having a midnight snack. The connection between the event and the food has on that relationship is where you have the nutrition information, the calories, the amount that the person ate. And with the food, that node right there just has the name of the food. Now, what I added at that time, and this is 8 years ago, before LLMs, was a food characteristic node. I would basically take the food and parse the different words and then add tags basically to each food characteristic, like whether it has sugar or whether it's a vegetable, whether it's a fruit, something like that. So you can kind of see this in a while. This is my ladies who lunch slide. This is two women having lunch. If you look at the purple nodes, those are the actual event nodes. So it's lunch. The blue nodes are the person nodes. The yellow nodes are all the food that they ate. So peas and fruit salad, rolls, chicken thigh. They had quite a lunch. And then they share this buttermilk pie. And what I did, the green nodes are the characteristic nodes. So you'll see a characteristic node called buttermilk, and that's linked to all the different things that have to do with buttermilk. And then pie is linked to other pies, as well as having characteristics like it's sugary. And so my goal was to start to build out this graph connecting all the different types of food to one another. So, using this idea, I would find someone who would benefit. So, I have someone who had less than two vegetables over a course of 2 days and more than nine sugar instances over 2 days. And so, I tagged people in the data set that look like they could use some help. And so, this is kind of the initial request as I imagined it. I am a 29-year-old man with a BMI of 42.2, and I want to lose weight. Recommend a lunch that I can purchase while I'm at work. And that's where it starts. So, the old way, when I was building these high quality recommendations, I considered three factors. Accessibility, he says he's at work, so we need something that's takeout or you could buy somewhere. Nutrition, the information about the food and his actual intake requirements. And then pleasure, which I think is something that's missing from most recommendations. A lot of people recommend healthy foods to people, but they never actually consume them. So we're not making any progress on what they're doing. So this is the old way. My approach was to find recommendations that the person would more likely use through person level similarity. So the query, I don't want to go through the query, but the idea is that people who eat similar foods will enjoy similar foods. So the idea that that this guy had five foods and similar with this other guy, maybe some of the things, and this other guy has a lower BMI, maybe some of the recommendations for lunch could come from other people's actual real lunches. So let me go to an aside. So that was the old way. I think it worked pretty well. I think I got some really nice recommendations, but then we now have the new way, which is large language models. Let me just go through the specs so that we can set the context. I'm using the Llama 3 instruction tuned model from Meta. It's the 8 billion parameter model that was updated around 5 months ago. So it's actually one of the smaller models. I chose that because I want to use it for an app, so I didn't want something huge or that would take a long time to process. I use Ollama for model management, and then I just use Python and LangChain to just bring it all together. So let's go to the new way. We've got this guy. He gives us this information. He's 29 years old. He has a BMI of this. He wants to lose weight. Let's do recommendations. So I started with the baseline of just asking the model what its recommendations would be. So it gave a lot of stuff, but this is kind of the core part. I should put an aside. I highlighted the hallucinations or things that I found like maybe a little problematic in red. So you'll see that when I do the LLM responses throughout the presentation. The first thing is the LLM says it's a healthcare professional. So I'm assuming it's getting information maybe from a healthcare professional website or I don't know where it is. Again, the black box issue. But the idea is this is professional information, which is, I guess, good, but I still don't know where it comes from. And it does say it wants healthy and it's a healthy and convenient lunch. These are the 5 recommendations it gives: a grilled chicken sandwich, a lentil soup, quinoa salad, a bowl, Greek yogurt parfait, and veggie wraps. And I don't obviously know this person in the data, but I would wonder which ones he would most likely want. And that the recommendations are pretty far from where he's actually eating. I'm not sure that he would actually do any of these recommendations. So then I thought, well, what if we added some preferences to the prompt? And so that's what I did. I added a preference that said, I like pizza and soda, help me out. And so the model responded with this idea of a lighter type of pizza, like a whole grain crust or California crust pizza, which definitely doesn't taste the same as regular pizza, or having a smaller size or slice. And then the soda was Sprite. And the recommendation substitution is a low calorie, unsweetened tea or black coffee, which is very different from Sprite, or a fizzy drink, maybe a sparkling water with a squeeze of lemon or lime, which again is very different from Sprite, and I'm not sure something that would get people starting on a healthy path. So when I think about high quality food recommendations now, I still think they should be personalized, meaning they should consider people's history. They should consider their preferences. I also think they should be customized because different situations, if you're not at home, it's different than when you are at home and you can cook. If you have allergies or if it's for a special occasion, I think you should be able to ask the LLM specific questions given a particular circumstance or event. So I really want the recommendations to be meaningful. I want them to be useful. And then I really need them to be accurate because we're talking about people's health. So our goal is to get a takeout lunch given dietary restrictions. The old way was Cypher queries, doing a similarity match between people, and then kind of finding a lunch among the lunches that those people had. The new way is using the large language model. So first, I use a RAG approach, a Retrieval-Augmented Generation approach, where I do embeddings, and I'll go into that a little bit, that come from the LLM. And then I also attempted to use LLM to make Cypher queries. So I'm going to go through both of those approaches. Um, So again, the old way to make the high quality recommendations, thinking about accessibility, nutrition, and pleasure. I think what I'm excited about with LLMs is that I can include other things like textures and colors and substitutions. LLMs, I don't know when I started out, I didn't know what the LLM actually knew or understood about food. So I started with some prompts around that. So I asked Llama 3, can you give me some crunchy foods? And I thought it did a great job. I felt like there's a lot of hallucination issues in places, but crunchy foods, it's chips and crackers and pretzels and nuts and croutons, things that make sense, seeds. Um, with the fresh fruits, it went a little strange with pineapple chunks, and then under fresh fruits, it has snack bars or granola bars, which means there's a category issue somewhere in there. And then under crispy fried foods, I've never had a crunchy sweet potato fry, but maybe they exist. I don't know. But there are some places where it got some things wrong, but definitely was able to provide crunchy food. So I know that within those embeddings, the idea of crunchiness or texture exists. Color is another thing that's important with food. So I asked, what are the colors of these particular foods? And it did a great job. Everything was accurate. The grapes come in different colors. It just gave me purple at first, but then when I went back and said, well, are there other colors of grapes? Then it gave me a whole diatribe about grape color and wine grapes and all kinds of things. But it even knows brand names like Cheetos. So there are lots of opportunities to understand the colors of foods as well. And then the final thing, which is probably the most important, is getting substitutions. So milk is a very common allergy for people or intolerance. And it was able to tell me almond milk, soy milk, and coconut milk as potential other things that people could use, as well as why you might use it and under what circumstances. So it is clear that the model knows things about food and can understand things about food. It's just not clear whether how they're representing and how it's being represented in the embeddings, and if I can get that information out. So for the embeddings, for all of this, everything going forward, I use Neo4j GraphRag library. The three methods that I focused on were the vector retriever for the embeddings, vector cipher retriever for embeddings with dealing with constraints, so injecting some cipher into the query, and then the text-to-Cypher retriever, which is the one that creates cipher using the LLM. So this is where I did the embeddings. Instead of having those two characteristics that I created, I now put black boxes there because now I have embeddings on the food node and I have embeddings on the meal node. I don't know what they represent. They have a length of 7,046. There's a lot of information in there, but it's not clear how to necessarily tease it out. So I started simple. I said, give me the similarities, the closest embeddings for Apple Raw. And the results were not exactly what I expected. Pear seems right, Asian pear. I was surprised by the specificity. But I also got orange. We have a saying in the States of comparing apples to oranges, this idea that they're not the same thing. And orange came in second. And then I also got turnip raw, which I think texture wise, maybe they're similar, but I was really surprised by that. And then I got mango raw. So I was surprised by what I was getting in terms of the embeddings that way. So then I went back and I started to add cipher to the query. So instead of allowing it to be all foods, I just specified just give me other fruits, apples, bananas, dried fruits, nothing else. And once I added the cipher query and I put it into the LLM, I started to get the results that I expected and actually wanted. So if you like apples and they're not available to you, here's a list of 4 things you might want to try instead: a pear, a banana, a kiwi, a mango. To me, it made total sense. The model also spit out that remember these suggestions are based on general association and flavor profiles rather than exact direct substitutions. So there might even be some space to add more information. And so that was really important. So I also did meal embeddings as well. And I started with kind of a strange meal, but I started there because I thought it was a good base case, which is a toddler formula, Pediasure, and a Chinese pancake. This is an actual meal that exists in the data. And so when I looked at the similarity, what I saw was initially the model just started replacing the formula with another type of liquid. So there's another meal in the database that's yogurt with the Chinese pancake. And then there was another with hot tea and the Chinese pancake. And then it shifted to what looks like maybe other Chinese food. So hot pepper sauce with broccoli and wonton soup. And then there's a ramen soup. So I wasn't unhappy with those embeddings. And I think with Cypher, I can get to the types of recommendations that I'm really looking for. So the last part of this presentation is where I'm trying to get the LLM to write Cypher, to get the queries around a recommendation. And I started off way in the weeds and it didn't go well. So I went way back to go to something very simple and direct. And so the prompt is, I would like a lunch under 1,000 calories that includes cabbage. And the reason I did 1,000 calories is because I wanted to have a lot of options for the lunch. And then cabbage is kind of just a random vegetable, but there are a lot of meals that have cabbage in them. This is just the setup. There's the connection to the database is the first, is the driver, and then you talk about the LLM. The reason I put this up there is for the retriever, you have the option to include the schema and examples. They're not required. I found for my use case, examples were absolutely necessary to get Cypher that was helpful to me. And that the schema was very important and was used, but I didn't have my data set up in a way to make the best use of it. So let me just show you the schema that I had. This is just the schema written out that I showed at the very beginning of the presentation. You have a person node, an event node, a food node, and then you have your relationships, has an event or consumes a certain food. So that works fine. Where I had trouble is when I was putting in the prompts to the LLM, it knew the node name. So it would put things, it would add like food to the query, but the way that I had the data input, it didn't match. And so I would get all these queries that didn't exactly work with what I was trying to do. I did find when I gave examples, so I put this example in, I would like a lunch under 500 calories that includes milk. And then I added the query for that, which is a very simple query. Once I put that example in, I definitely got out the information that I wanted. So here's an example of putting that query in, and the output for that query is definitely what I'd look for. It just replaced cabbage with milk and it replaced the 500 with 1,000. Very simple, but it gave me the right results. And then when I add it to the LLM, I get this output, which is very detailed. Chicken breast, chopped cabbage, which what I was looking for was cabbage, the tortilla, shredded carrot, low fat. I mean, it gives this whole meal, and then it gives me an approximate amount of calories. Where this works for me is that it's a complete answer. Where it doesn't work for me is it doesn't match any of the data that I have in the database. And that makes it difficult to track the nutrition. And it's not giving me enough information to to really track the nutrition. So I have that picture of like the robot playing chess. It's like the model is like thinking of all these other things when I just really want it to do something specific. So I would have to do some more work around it to make it what I'm looking for. So what I learned from the LLM generated Cypher queries, that last part, is that the names in your schema really matter because the the model is looking for a complete understanding of your data. So when you name a node food, it's expecting it to be food and expecting it to look a certain way. And so I think if I were to focus on this particular approach, I would design my schema very much, very use the schema and the words very carefully. So I might not just have one food node. I might split it up into fruit and vegetable nodes. I might do some different things. I think there are a lot of capabilities with that possibility. I also learned examples are, I would say, critical for my use case, and I would have more of them and use more varied examples so I can have different prompts. I'm not sure it's using my data, and so that is a concern for me because I need the accuracy. And it absolutely, and that's true for probably all of the prompts that I've done, there has to be an output pipeline or output layer to like make sure that things are accurate because I'm not trusting all of the pieces coming together for the accuracy, especially for the nutrition. But as far as conclusions are concerned, I may need a stronger model to generate the cipher that I'm looking for. I did a lot of different things and I wasn't happy with the results, but it could be that the model is not the best model for what I was trying to do. But my main conclusion is the embeddings with Cypher give me everything I need. I feel like, well, I know that the recommendations I'm getting with Cypher allow me to do the customization that I'm looking for, get the accurate data because I know it's actually using my data. I can reference it back and do the calculations I need, and it can give me all the pieces that I need for my purposes. So I'm going to preview. Maybe I'll be lucky enough to present another time. So it won't just be a sequel, it'll be maybe a series. My next steps are to really tackle unstructured data. I'm already working on it. This is Aquafina, and there are Harper's Bazaar does this series of what famous people eat in a day. And so taking that data and transferring it into an unstructured graph model is what I'm working on now, and also adding the idea of a multimodal model as well. So those are some next steps in this process of building this really strong, robust food recommendation engine. Um, Thank you. I have more to share in terms of this process and things. So this is how you can find me if you are looking for, and if you have questions that I did not answer or you that come up later. And that's my presentation.